Hi student, in this video we will see the difference between the immunogenicity and the antigenicity. These two terms are related to the antigen, which can be confusing sometimes. Before we start with the topics, I would request to all of you, please share this video and please subscribe our channel and press the bell icon to get more updates from our channel, and please like our videos. So let's get started. Adaptive immune responses arises as a result of exposure to foreign compounds, and the compound that evokes the response is referred to as antigen, a term initially coined due to the ability of these compounds to cause antibody responses to be generated. And antigen is any agent capable of binding specifically to T cell receptor or an antibody molecules, may be membrane bound or soluble. And the ability of a compound to bind with the antibody or T cell receptor is referred to as antigenicity. So antigenicity is the ability to combine with the final product of the humoral or cell-mediated immunoresponse. It is not activating the immune response, rather it combines with the final products of the immunoresponse. And there is a functional distinctions between the term antigen and immunogen. An immunogen is any agent capable of inducing an immunoresponse and is therefore immunogenic. So immunogenicity is the ability to induce humoral and or cell-mediated immunoresponse. We know when B cell and T cell get activated by antigen, it results in effector cell and memory cell. For example, if B cell gets activated, it will differentiate it into plasma cell which secretes antibody. You can see here a virus which is a antigen, is a foreign particles, is joins with B cells, is a native lymphocytes, and after the joining of B cells, after the joining with the B cells, this native lymphocytes activated the B cells, and this B cell gets activated. When the B cells gets activated, it will differentiate it into plasma B cells and memory B cells, and this plasma B cells secreted antibodies. So we can say B cell plus antigen which activates the plasma B cells and memory B cells, and this plasma B cell secretes antibody. And such antigens are called immunogen more appropriately. And these immunogens are large molecules with molecular weight at least greater than 10,000 Dalton. And that is why we can induce the immunoresponse. We just saw when B cells get activated, it secretes antibody, and the antigens which have the property of antigenicity will combine to these antibodies. And such antigens are called haptens, and these haptens came from Greek word hapten, and which means gaps, and this hapten failed to induce immunoresponses in their native form because of their low molecular weight and their chemical simplicity. And haptens are antigenic but not immunogenic, and these compounds become immunogenic when they are conjugated to high molecular weight physiochemically complex carriers, and which is called carrier proteins or carrier molecules. Thus a hapten is compound that by itself is incapable of inducing an immunoresponse. However, when hapten is conjugate with a carrier molecules, an immunoresponse can be induced against it. So from this topic we can say all immunogens are antigenic, but all antigens are not immunogenic. To understand all immunogens are antigenic but all antigens are not immunogenic, I give a funny example. Suppose you are a boy and you want to eat pizza. You convince mom to make pizza and she makes it for you. So here you are immunogenic because you inducing mom to make pizza. Mom here is immunosystem who gives you the final product, that is pizza. Now when you enjoying the pizza, your brother works in and he also eat pizza. But here your brother is antigenic because he did not convince or inducing mom to make pizza, but he is just eating the final product, which is here pizza, like Haptens, only binding with the final product. Now since you convince mom to make it and you are also eating the pizza, so you are both immunogenic as well as antigenic, but your brother is only antigenic because he is just eating the final product just. And thus we say all immunogens are antigenic, but all antigens are not immunogenic. This means all immunogens are antigenic, meaning it can react to the end product of immunoresponse, and it makes sense, right, that if immunogen can induce the immunoresponse, it can also bind with a final product of immunoresponse. But all the antigens cannot be immunogenic because only high molecular weight antigen can induce the response, right? So they are antigenic but not immunogenic. I think this example will help you to understand the differences between the antigenicity and immunogenicity as well as antigen and immunogen. A substance must possess the following characteristics to be immunogenic. So there are some requirements for immunogenicity. That is foreignness, size, chemical complexity, dose and route of administration. The most important feature of an immunogen is that an effective immunogen must be foreign with respect to the host. The adaptive immunoresponse recognizes and eliminates only foreign, which is non-self antigens. And self antigens are not recognized, and thus individuals are tolerant to their own self molecules. Even though these same molecules have the capacity to act as immunogens in other individuals of the same species. And the second requirement for being immunogenic is that the compound must have a certain minimal molecular weight. And there is a relationship between the size of immunogen and its immunogenicity. In general, small compound with a molecular weight less than 1000 Dalton, example of less than 1000 Dalton molecular weight is penicillin, aspirin, are not immunogenic, and those of molecular weight between 1000 to 6000 Dalton. An example of this molecular weight, the range of the molecular weight is insulins, adrenocorticotropic hormones, may or may not be immunogenic, and those of molecular weight greater than 6000 Dalton, example of this range, albumin, tetanus toxins, are generally immunogenic, and the most active immunogens tend to have molecular mass of 1 lakh Dalton or more. And in short, relatively such substances have decreased immunogenicity, whereas large substances have increased immunogenicity. And the third characteristic necessary for compound to be immunogenic is certain the degree of chemical complexity. For example, homopolymers of amino acid or sugar are seldom good immunogens regardless of this size. And similarly, a homopolymer of polygamma D-glutamic acid, it founds in the capsular material of Bacillus anthracis, is a bacteria, and with a molecular weight of 5000 Dalton, but it is not immunogenic because the absence of immunogenicity of these compounds, although of high molecular weight, are not sufficiently chemically complex, and virtually all proteins are immunogenic. Furthermore, the greater the degree of complexity of the protein, the more vigorous will be immunoresponse to the protein. Carbohydrates are immunogenic only if they have a complex polysaccharide structure or part of chemical molecules such as glycoproteins. Nucleic acids and lipids are poor immunogens by themselves, but they become immunogenic when they are conjugated to proteins carriers. So nucleic acid and lipid act as a hapten. And the insufficient dose of immunogen may not stimulate an immunoresponse either because the amount administered fails to activate enough lymphocytes or because such a dose of renders the responding cells unresponsive. And beside the need of administer a threshold amount of immunogen to induce an immunoresponse, and the number of doses administered also affect the outcome of the immunoresponse generated. And the route of administration also affected the outcome of the immunization, because this determines which organ and cell populations will be involved in the response. Immunogens can be administered through a number of common routes. That is intravenous. Intravenous means into a vein. Intradermal. Intradermal means into the skin. Subcutaneous. Subcutaneous means beneath the skin. Intramuscular, that means into the muscle. An antigen administered via the most common route, namely subcutaneously, generally elicited the strongest immunoresponses. This is due to their uptake, processing, and presentation to effector cell by Langerhans cells present in the skin, which are among the most potent antigen presenting cells. Antigen administered subcutaneously moves first cell present in the skin and to the local lymph nodes, and intravenously administered antigens are carried first to the spleen, where they can either induce unresponsiveness or tolerance. And if presented by antigen presenting cells, generated an immunoresponses. And orally administered antigens, that is the GI tract route, gastrointestinal route, elicit local antibody responses within the interstitial lamella porphyria. So in this topic, I discussed on the differences between the antigenicity and the immunogenicity, and this distinction between the terms is necessary because there are many compounds that are incapable of inducing an immunoresponse, yet they are capable of binding with components of the immunoresponse immunosystem that have been induced specifically against them, and thus all immunogens are antigens, but not all antigens are immunogens. So I hope this video will help you to understand the differences between the immunogen and versus antigen, as well as immunogenicity versus antigenicity. If this video help you, please share this video among students, and please tell them, please subscribe our channel, and please press the bell icon. Please like our video. Thank you from Knowledge of Life Edu.